Hello everyone, welcome back to Medical 360. RE-NEET 2026 exam is officially over, but still there are a lot of questions that are creating debate and buzz after the paper. Yes, there are a lot of questions from the physics and chemistry that have created a buzz among the students for the bonus marking, and we are going to cover such questions in this video. We are talking about the controversial questions of physics and chemistry that need to be limelighted in this video. But before we begin, do not forget to subscribe to Medical 360, and also we are thankful to SRM University for sponsoring this video so that we can bring all the information updates to you quickly. In this video, we'll be talking about the code 60 question of physics first. This is question number 43 from code 60 and it is based upon Vernier caliper. Basically, it is based upon measurement error. That is the first chapter, unit dimension error, where we learn about how we take the measurements and how we calculate the actual lengths or the actual measurements along with the error. So basically in this question, the main scale division has been shown to be 1 millimeter and the number of divisions is 10. Then it says when both the jaws touch each other, the vernier scale shifts to the left of the main scale. To the left of the main scale, that means, or that clearly indicates, that there is a negative zero error in this, in such a way that the fourth division coincides with the division of the main scale. If this vernier caliper measures the length of the wire to be 1 centimeter, the actual length of the wire would be. Now, if you have to give the answer instantly, the measured length of the wire is 1 centimeter, so the actual length would be greater than 1 centimeter, and hence 1.04 centimeter would be the correct answer if there was a negative zero error. Now, let us see how can we solve this question. If I go step by step, the first step would be to calculate the least count. Now, what is the least count? We are already aware that the least count is the smallest difference or the smallest measurement that any device can detect. In order to calculate the least count, we divide the main scale division by the total vernier division and we obtain the least count to be 0.01 centimeter or 0.1 millimeter. Next, we calculate the zero error, whether we have a positive zero error or whether we have a negative zero error. Now, first thing, if the vernier scale division shifts to left, there is a negative zero error. So, in this case, we will be calculating the negative zero error, and the formula for the negative zero error is minus in the bracket total vernier division minus coinciding divisions bracket closed into least count. And substituting everything, we found that the negative zero error value is minus 0.06 centimeter. And after that, when we are calculating the actual length is equal to the measured length minus zero error, that is 1 centimeter minus in the bracket minus 0.06 centimeter, that adds up to 1.06 centimeter. So the actual length of the wire should be 1.06 centimeter, but the exact answer was not in any of the option. Instead, 1.04 centimeter was mentioned. If the most appropriate answer is considered by NTA, then 1.04 centimeter would be the correct answer. But since it is not the exact answer, there can be an equal probability that NTA might provide bonus to this question for all the students who have attempted this question. Remember, bonus is not applied for the students who have not appeared or attempted for this question. So if you have attempted this question, there is an equal probability that you can be given a bonus marks or plus over this question if NTA considers 1.06 centimeter as the correct answer for this question. Okay, the next question that we have is again from physics, that is question number 36, code number 60. The question says an electromagnetic wave traveling in a lossless dielectric medium having a dielectric constant 9 has the electric field this, and it has asked which of the following are the incorrect choices with respect to this equation. The first is the direction of propagation of the electromagnetic wave is along the plus z direction, but actually it is correct because here we have z, so this is a correct option. Next, the speed of the electromagnetic wave inside the medium is 10 to the power 8 meter per second. Again, it is correct because electromagnetic waves are those waves which travel irrespective of any medium, and the speed of the electromagnetic wave is equal to the speed of light. The next is the wavelength of the electromagnetic wave inside the medium is 300 meter. This statement is incorrect. The reason why it is incorrect is if you see the calculation of the electromagnetic wavelength, we have the wave number is equal to omega by v. From there we get the value of k, that is the wave number, as equal to 2 pi into 10 power minus 2 radian per meter. And after that, when we calculated the wavelength using the formula 2 pi by k, we obtained the wavelength of this electromagnetic wave as 100 meter and not 300 meter. So this statement, option number 3, is incorrect, because the correct wavelength of this electromagnetic wave is 100 meter. And the last statement, or the last option, is the magnetic field is given by the relation By is equal to B naught sine in the bracket Kz minus 2 pi into 10 power 6 t. Actually, this should be not B naught, it should be E naught by V. So overall over here, this seems to be incorrect, and now you know the reason why. So there are two statements which are incorrect, option 3 and option 4, and that is why this question can also be considered for bonus. Okay, another question that has created a buzz among the students is a question from chemistry. A lot of people are saying that it should be marked as a bonus, but I do not understand why shall it be provided a bonus mark when the explanation is quite clear. So there will be no bonus according to me. There are 4 coordination complexes given over here for the different central metal ions, and we have been asked to calculate the spin only magnetic moment that will be highest for which of the complexes. So we are already aware that the spin only magnetic moment is dependent or directly proportional to the number of unpaired electrons. Higher the number of unpaired electrons, higher is the spin only magnetic moment for that coordination complex. We have 4 coordination complex, and in order to calculate the number of unpaired electrons, we need to know their oxidation states as well as the type of ligand which is present along with them, whether a strong field ligand or weak field ligand. In this case, cobalt lies in the +3 oxidation state, titanium lies again in the +3 oxidation state, manganese lies in the +3 oxidation state, and iron also lies in the +3 oxidation state. If I talk about the electronic configuration in these respective oxidation state, cobalt 3+ has 3d6 configuration, titanium has 3d1 configuration, Mn3+ in this state has 3d4 configuration, and Fe3+ in this case again has 3d5 configuration. Now let us talk about the type of ligand. Ammonia is acting as a strong field ligand, water is acting as a weak field ligand, and cyanide acts as again a strong field ligand. Now in this case there will be 0 unpaired electrons. In this case there will be 1 unpaired electron. In this case, actually cyanide, being a strong field ligand, causes the pairing of only 2 electrons in order to maintain the hybridization as D2sp3. So 2 electrons still remain unpaired although there is a strong field ligand present. So there will be 2 unpaired electrons present in this case, and in the last one, 1 unpaired electron will be present. So in this case, the number of maximum unpaired electron is present in the third option, and therefore it will be the correct answer having the highest spin only magnetic moment. So this question shall not be marked as a bonus, and option 3 will be considered the correct option for this, having maximum 2 unpaired electrons. And at last, do not forget to subscribe to Medical 360. These were the controversial questions of RE-NEET 2026 which we have entirely covered. If you have any other questions still related to this video, or any other question related to the RE-NEET 2026 examination paper, do comment in the comment section, and also let us know how much are you scoring after the unofficial keys have been released by different coaching institutes and organizations. Thank you for watching this video.